So good to be here. Our solution is connectivity through decentralization, and our all-star Power Rangers team is Jeffrey, Laurel, Niels, and myself, Gautam. So what are we really looking at here? What's the problem? When we look at the thread, DER is really growing up rapidly, as you can see on the graph on the right. The adoption is really improving and growing, whereas the adoption curve, we're at stage 2, where we really need to integrate DER resources with our renewables. But we already knew that. This is just to provide some background. Next slide, please, Jeff. So what is our solution? So I'm just going to give a quick solution stack here. So we have 3 main solutions that are sort of inversely linked on capital intensity and scalability. We look at marketplace and network solutions. We look at DER build out and harmonization with the grid. And finally, we also think about what DER naive electricity transmission and distribution would be for consumers and utilities. And they'll draw this out in more detail. But for now, I just want to talk about, next slide, please, Jeff. I just want to talk about what the impacts are for both consumers and for utilities. So when you look at consumers, you look at costs and benefits. So for customers, for example, they have high capital investment costs for DER resources, but they can make a lot of their revenue back with programs like grid net metering. But for consumers that don't have DER resources, unfortunately, their retail electricity rates go up. But for utilities, next slide, please, Jeff, we see that there are a lot more benefits and opportunities in terms of costs, high rate sales, decreased customer dependence, lower revenue, but they also benefit because they don't have those transmission and distribution costs that they really have to think about. But for non-participating customers, unfortunately, we see that it's not a great move again. And so now to the financial model, Niels.
So our approach is trying to determine how much prosumers will benefit from the DR system. We assumed 100 megawatt solar rooftop and storage penetration in 2019 and 500 megawatt in 2025. We did not consider capital cost, and we used the data given for EV load growth in the Excel sheet. We used historical energy prices for 2019 and used inflation to predict for 2025. We modeled EV and storage during peak load, peak solar production, and storage discharge during peak load. This was a simple attempt to model what our utility could be worth to, or utilities managing could be worth to prosumers. And then in the next slide, we can see that this value is approximately 6.5 million in 2019 for all prosumers and 29 million in 2025. So obviously there's a major opportunity here, and this is only considering energy prices. So if we included transmission and distribution and capacity prices, it would be even higher. Done. Jeff?
Yeah, so assuming that everything that Neil said, counts, I think it's important to take a step back and think about the mapped ecosystem of different data, power, and payments assets in the ecosystem. And there's really a double-sided network here, which I think allows for an interesting Airbnb type play, where Avangrid is the network operator connecting consumers, prosumers on one side of the equation and developers on the other side. So prosumers save money on their electric bill and monetize DER assets thereby. Prosumers pay a grid maintenance fee, as well as for access to the network, and including energy management access and services and value-added services and liquidity for the electricity kind of securities, if you will, that are being generated through the prosumer model. So thinking about the specific product features that I think will drive value in this space, I think the residential product will really require a lot of behavior and consumption insights that are made possible through smart metering, IoT-enabled devices, as well as data analytics. Standardized transaction frameworks, I think, also will be super important to the extent that consumers need standardized contracts to execute and clear their electricity to the grid and then make sales. Supporting and maintaining integrations throughout the framework and throughout the ecosystem will be massively valuable and important to maintain efficiency and optimality. On the commercial side of things, there's really a room here for Avangrid to be a DER consulting and financing company in which they're designing bespoke DER solutions for commercial properties, as well as financing them to the extent that financing them could be cheaper than upgrading substations and other infrastructure. And finally, on the industrial side of things, I think there's a really interesting play in terms of process automation and manufacturing, which will optimize electricity consumption. So I'll pass it off to Laurel to talk about the technology that enables this all.
Hey, so our proposed system is an ensemble model composed of 2 random forest models that will be trained based on historical live and weather predictive data on an annual and a daily basis. The system will then communicate this data to both a home-based and an app-based interface that ideally will be user-friendly and interactive. It'll also communicate with smart home devices. And overall, we hope that the system will be super user-friendly, and it'll help our community optimize their end use and stabilize our grid. So if you mind, next slide. We know that as DERs are implemented, there are definitely some potential issues that will arise, one of which is a disproportionate impact on low-income households. So some ideas we have would be a partnership with low-income housing for a seamless integration of these systems. And on that, these are some of the things that we think will lead to success. Next slide. Here. Any questions?
So I'm interested in the consideration of low-income housing to offset, potential adverse impacts of this. When thinking of that in the context of the proposal of Avangrid sort of being this consulting company for the development of these systems, would the, I guess, expand on that concept for me if you can, on that thread. Is there a link between those two concepts, or are they sort of, do we think of them separately?
Yeah, I can jump in. I have something, unless anybody else wants to take it.
No, go for it, Jeff.
Yeah, so I think that there's a huge opportunity here, because if you think about the negative externalities of energy consumption inequities in communities, I think that there's an opportunity to address those externalities, which might open up financing opportunities. For example, if you're thinking about building in DERs, this could also lower the urban heat island effect. So a lot of these communities, and in particular like public housing communities, so if you think about like big cities like in Philadelphia, for example, where I'm hacking from, the Public Housing Authority is one of the largest real estate owners in the city. So if you're partnering at a stakeholder mano a mano basis with these organizations that have large holdings to develop DER solutions to improve energy equity in these communities, you could have access to HUD financing as well as DOE grants and that sort of thing to lower the cost burden, but also the public health externalities associated with not having access to electricity.
Okay.
Does that answer your question?
Yeah. Anything on your end, Hara?
Yeah, this you have to speak about that the market that the US has growing. Do you think your solution is interesting just for the people that has the photovoltaic plant, the electric vehicle, and the storage, or is interesting too for the people that has to invest in these equipments? Your business model works for both, or just for one of them?
You mean participant and non-participant?
No, I mean that the participants that want to participate but doesn't have already the photovoltaics or doesn't have already the electric vehicle or the storage. They want to do it, but they have to make the numbers and decide, I have to invest in that, to participate in that. It's interesting, your product for these ones or just for the ones that already have the structure?
I can speak to something on our digital system. We intended that with the app-based data analysis, we'll actually be able to help optimize people's electricity use and save them money for even non-participators who don't have any sort of photovoltaics or storage systems yet. So that would be one way in which people could start taking the steps to save money for the capital cost of these systems, but definitely some incentive incentive programs would be something we would hope to further explore.
Yeah, and I think just to add real quick there, I introduced this sort of the DER adoption curve. I think our prime focus here was to look at sort of integration with the photovoltaics and then the storage and the EVs. But I think we also want to work with this new model that we suggested, where it's also going to help non-participants to really build out that ecosystem and not just focus on one kinds of stakeholder.
Right.
What are the incentives for asset owners to opt in to this system versus them thinking maybe their assets would be more valuable to them when not sharing the capacity with the grid at large?
I think
that's a great question. I think that it depends, right? I mean, like, it depends on what your actual utility bill is and how much electricity you consume. So I think for people with, maybe like one battery and not a car, and they're kind of just using it to keep their solar power generation on at night when they're, just watching TV or something. I just don't think it necessarily makes sense. But I think the biggest play here is on the industrial and commercial side of things, where you have these large products and these large buildings. And I think it's really interesting in the office space. Like if you think about like New York City or Philadelphia, for example, where there's lots of large buildings, if you can somehow leverage their parcel and their like air rights to then,
We're out of time. Please wrap up. Thank you.
Yeah. But yeah, I think that's the interesting play there.
Thank you so much.
Thank you.
Thank you.
Great.
Thank you.
Thank you.
Bye.